Hi everyone, we are the JRobots and we made a dog arm brace. On the left is an exploded view and motion analysis of our prototype in SolidWorks, which is based on an actual dog arm walking motion. And on the right is a footage of our prototypes fitting on the model's leg. The brace was successful in limiting the mobility of the dog's arm while still allowing a normal walking motion and sitting position.
Here are the simulation of our individual parts. As you can tell, the Valdez stresses are really low compared to the yield strength. We only saw one deformation, which was on the store-bought hinge, but we don't expect it to break since it's made out of metal.
These simulations informed our material requirements. We ended up choosing polyoxymethylene, or POM, in order to maximize yield strength while minimizing cost and weight. We selected POM because it is tougher and cheaper than ABS, among many other plastics, as well as because of its high yield strength, the fact that it's recyclable, and the fact that it's relatively weather resistant.
So a couple of the main modeling assumptions. We intended our brace to act as a cast. We thought a circular shoulder piece would offer more of a secure fit, as shown there. And some other assumptions we made were that the hinges would align, and we measured my dog and modeled the parts off after those measurements. Then during the design process, we measured the store-bought thread pieces and adjusted our model accordingly to those measurements. We lowered the tolerances, and then we ended up redesigning some parts, as I'll explain in the next slide. While designing, we created an assembly in SolidWorks, and then we realigned the hinges so that instead of them being on the outside, we have them on the inside of the shoulder piece. Then we made a cut to offer less strain at the front of the dog's shoulder.
These are the tools that assisted during the design process and assembly of our prototype. Teamwork skills that assisted during the design process include communication as we updated each other on our progress of our designated task. We joined Zoom meetings to discuss the future of the project. We approached problems as a team and collectively found solutions, and we provided each other with comments and suggestions on possible improvements and or modifications on our designated parts. Thank you for joining our prototype demonstration, and here are some of our future endeavors.